In this video, we're going to build a simple treasure chest, but by the end of it, I'm pretty sure you'll understand almost every mechanic you've ever played, and I'll prove this system to you with plenty of in-game examples, so let's jump right into it. Does this sound familiar? You want to learn how to create your very own game. So you begin by watching a tutorial. You copy their code, the game works, you feel confident, so you start your own project. You open your desired engine, and you get stuck. And then you go right back and watch another tutorial. Now, why does that happen every time? And how can we escape this loop? Every beginner thinks professional developers know hundreds of secret game systems. Spoiler, they don't. The difference isn't that experienced developers know more mechanics, it's that they see the patterns beginners don't. Almost every mechanic you've ever played is just a combination of a handful of tiny building blocks. And once you start seeing them, I promise you, you can never unsee them. Let's begin at the root of this whole situation. Tutorials really aren't the problem. Most tutorials teach solutions to a single problem. For example, how to make a door, a chest, or a button. Instead of showing us or explaining how and why every interactive object really works. Tutorials are great, don't get me wrong, but only if you're learning the patterns instead of memorizing solely the solutions. I remember my past self watching tutorial after tutorial, learning only one mechanic after another, instead of thinking how is it all built from the ground up. I still remember the day when I realized these patterns. I would watch tutorials for everything and spend so much time trying to memorize the exact solution. But then one day, the patterns became more and more blatant and it finally clicked. I felt so free and game development became a fun, creative process rather than a daunting workload. Right then, so let's head over and create that chest. Throughout this process, let's try and discover the 5 building blocks. So, let's say we want to build a chest. What are the first things we have to think about when creating this object? For example, we would like the chest to open when the player presses a key on the keyboard. So how does the chest know that someone pressed E on their keyboard? Well, we'll need some sort of input mechanic. We need the player to press a key to open the chest. Another core feature of interactive objects is that the player has to be decently close to the chest to actually open it. So, how does the chest know the player is nearby? Well, we'll need some form of detection. We need to check if the player is within interaction range of the chest. Once we interact with the chest, we would like it to somehow visually open. So, how do we make it look open? Well, through transformations, like rotating the lid when opening or changing the sprite, we can clearly communicate with the player that the interaction has been completed. We also have to think about how does the player get the reward from the chest. So we'll need some form of communication between the player and the chest. One way from the player to interact with the chest and open it, and then vice versa for the chest to communicate with the player to give him a reward. And last but not least, how does the chest remember if it's already open or still closed? So we'll need some sort of state and logic to keep track of all of those systems. Now the logic and the states connect all of the blocks together. It can remember if the chest is open or closed, and also run specific logic for opening and giving a reward to the player. Now you might think, well, that's just one example. How can we be sure that these 5 building blocks are also used in other game objects? Well, let's rapid fire through a few examples. A door. We need an input from the player, detection to see if the player is close enough, transformations to actually rotate the door and open it or close it, communication from the player to the door to open it, and state and logic to run the code, as well as keep track of if the door is open or closed. A moving platform. In this case, we don't need any input. We might want to detect if the player is on or off the platform. We'll move it back and forth, so that's a regular transformation. And in this case, actually, we probably don't need as much of the communication and state logic, but we will still use the other building blocks. How about a button? Very similar situation. We need an input from the player to know when the button is supposed to be pressed, detection to see if the player is close enough to the button, transformation to slightly push the button forward and back, communication to run signals from the button to other game objects like doors or traps, state and logic, remember if the button is pressed or not. How about the checkpoints? We might not need any input from the player, but we surely need detection when he comes into the range of the checkpoint. Most likely we don't need any transformations, but we should have a state and logic script keeping track of the valid checkpoint to know if it's being currently used or not. An NPC is actually quite close to a chest. We need an input to know when the player wants to talk to the NPC, detection to be within the range of the NPC. Transformations can be playing an animation on the NPC as if we're talking to him, communication between the player and the NPC in case we want to do any trades or choose a given answer in the conversation, and some example state and logic to know if the given NPC even wants to talk to us. How about the bullet? No need for input, but we need to detect when the bullet hits something, so we will need a small detection radius around the bullet to know when we hit something. We'll have to move the bullet straight forward at a high speed, so that will be our transformation. We'll have to communicate the amount of damage we'll have to deal to the hit enemy, and that's pretty much all a bullet is. Very similar with an enemy, we'll have to have a detection radius around the enemy to know where our player is, rotate and move the enemy towards the player, as in our transformation, have another detection radius for the attack range, and then communicate the amount of damage we'll deal to the player. We should also have some state and logic thinking if our enemy has different kind of attacks, so it might be a heavy or a light attack, that'll be different states, and then the logic should run different kind of code. So, do you see the pattern? What are the most common things that appear in almost all of these objects? We were basically just describing how they work. And without realizing it, we've discovered the 5 questions I ask every time I build a mechanic. Input: how something is controlled. Detection: how something knows what's happening around it. State and logic: the rules and decisions of our object. Transformation: how something moves or changes. Communication: how objects interact with other objects by references, signals, or function calls. Okay, now, we've looked at doors and chests, but surely this doesn't work for something like a grappling hook, right? Well, let's take it apart. As for input, we need an input from the player to know when we want to shoot the grappling hook. For example, our left mouse button. As for detection, similar to a bullet, we'll need to detect when the hook hits a wall after being shot. The transformation of this object is probably one of the hardest ones, because we'll have to move the hook in the direction the player is looking until it hits something, just like a bullet. Once we hit a wall or a roof, depending on the player's angle relative to the point of hook contact, we can calculate how the player should fly through the air. But at the end of the day, it's just a change of position of the player, just in a different way. As for state and logic, we'll have to know when the player is moving or flying. The movement system will be drastically different when the player is just moving around with the grappling gun, or flying around when the grappling gun is attached to a wall or a ceiling. And we need a way to separate those states within our code. And last but not least, communication between the player, the grapple, and walls. The player has to communicate with the grapple to shoot it. The grapple has to communicate with the player to know how he has to move through the air, but also the walls should tell the grapple at what exact point it hit. Right then. So imagine you want to build anything in the future. Before, you'd probably search how to make it on a tutorial. But maybe now, you can ask yourself, does it detect something? Does it move? Does it need input? What objects does it talk to? What logic controls it? That's how independent developers think. From now on, every time you play a game, don't ask yourself, how did they make this? Ask, which of the 5 building blocks am I looking at? And once you start thinking like that, you'll stop needing a tutorial for every new mechanic you want to build. I hope you enjoyed this video as much as I enjoyed making it. I truly think we should all strive to become independent developers, because that's where the real magic of game development happens. I hope this framework clears some things out for you, and you won't feel as stuck as you did before. Consider leaving a like and subscribing, that helps the channel out a lot. And if you would like to join a like-minded community, consider joining my Discord server, first link in the description down below. I wish you the best of luck and create something special. See you in the next one.